As soon as the mousetrap is set, it has a huge amount of elastic potential energy. Once the trap is activated, the spring releases the potential energy and converts it into kinetic energy of the snapping arm. That kinetic energy is then converted into elastic potential energy and kinetic energy in the string. Both then turn into rotational kinetic energy at the axle which spins the wheels.
Friction at the axles was minimized by having a rolled up piece of paper and having the axle spin inside of it. This also allowed the axles to rotate with very little friction. Friction between the wheels and the ground was almost non-existent due to the CD's miniature width, and the wheels would just spin in place. In order to fix this, we added balloons around the wheels to increase the friction.
The bigger the arm, the greater the distance traveled, which would equal a greater amount of work, because work equals force times distance. A shorter arm would cause less distance traveled with the same amount of force, since it comes from the spring of the mousetrap and it's equal no matter the length of the arm. The power will be greater with a short arm because power equals work divided by time, and you'd be dividing by a shorter number since it'll take less time for the arm to go through its motion.
Newton's first law states that an object in motion will stay in motion and an object at rest will stay at rest unless acted upon by an unbalanced force. The unbalanced force is the spring of the trap tied with the fishing line. Newton's second law is F equals ma, and the force applied by the lever arm causes a unique acceleration to the unique mass of the car. The acceleration would change depending on the length of the lever arm. His third law is that for every action there is an equal and opposite reaction. The front wheels apply backwards force on the floor, which causes a forward force on the car, making it move forward.
A real-world example of energy transfers would be a skater. At the top of a half-pipe ramp, he is full of gravitational potential energy. As he goes down the ramp, the energy is converted from potential to kinetic energy. Then the skater moves back up on the other side, converting all its kinetic energy back into potential energy. The skater will go back and forth converting the kinetic energy into thermal energy.